Yay! 4. I use graphing techniques, approximate intervals. Alright, let's do some graphing techniques. Nope. Alright, graphing techniques. Alright, so calculator. On, and we have e to the x. Oops. E to the x. Where's e? Where e is? E x divided by 5 x squared plus 1. All right, it looks like something. What is our window? -10 to 10. All right, so let's see here. Use graphing techniques. We're not totally gonna lose our brains here. This is consistently increasing. It's going to be like this. And this 5x squared plus 1, this will never be 0, but it should have an interesting bit of something where 5x squared is negative 1. Okay, so it won't do anything particularly clever. We should have 2 lumps. Maybe a lump and a half. We'll see. Alright, so we're good. Let's zoom in. Yeah, that would be nice. Alright, so I think that ought to be nice. Move it to the right ever so slightly. How about we go from negative, hold on, about -2 over to 3. Let's graph that. All right. -1. Yeah, that's the critical part there, right? So each one of those is 1. And then we can trace. Let's see. 105. So we'll take that. Alright, so according to this, find out where this is increasing. Alright, well this is increasing. This is increasing everywhere from -infinity over to here. And it's decreasing to say 2-ish. And it's increasing again. So we're going to say that that actually occurs at 0, because that would make more sense. When x squared is 0, we would be at a local max, because we'd be dividing by the least possible, I suppose. All right, so we're increasing from negative infinity up to 0. And then we are increasing again from 2 to infinity, say. About, where is that exact one? Less and less and less and less and less. Yep. Say 2 was the low point. To infinity. Then we are decreasing where that's not. That's from 0 to 2. 0 to 2. And we would be concave up. Concave up. It's like we're concave up. Awfully close. Right in there someplace. At 0.4. So we're concave up only until right in through there, I suppose. So let's say negative 0.23, 0.23 up to 0.23. That looked good. So we're concave up from here. I'm sorry, concave up. Oops. Incorrect. Concave down. Concave up to this point. And then we're concave up again from there on forever. So that would be from negative infinity up to 0.23. And then from 0.23 up to infinity. Then we're concave down from negative 0.23. 0.23. Extreme value of extreme. Not there. 0.05. 1.05. 5, that's x equals 0. Oops, there's a maximum. X equals 0. And the asymptote doesn't count as an extreme value over this way because it doesn't actually have value. But we have a value y was 0.42, 0.37, 36, 35. No, back up again. Y equals 0.35. X equals 2. 0.35 at x equals 2. And inflection points, that changes up. We started here minus 0.23. Plus, that's a good fair guess. Good fair guess based on the graph. All right. Number 4. The function is that x at each point where x has local max, local min, or point of inflection. All right. So they already give us the so we'll just take the next derivative and set them off equal to 0. So this first derivative when x equals -2 and x4, those are our 2 points of max, min, or inflection. So we have to just check these points in the second derivative. So the second derivative of our function, so let's see, second derivative, so we can use we use product rule. We'll multiply it up. So this will be x squared plus 4x plus 4 times x minus 4. Then we'll have x cubed plus, let's see, 4 and minus 4, so there's no x squareds. Then we'll have 4x minus 4x squared plus 4x minus 16x and plus, 16 at the end. So x cubed minus 4, yeah. Alright, so it's x cubed minus 12x minus 16. So we plug in -2, we get negative, so f of double prime of -2 equals -8 plus 24 minus 16. That equals 0. That's an inflection point. F double prime of 4 is going to be 64 minus 48 minus 16. Ooh, also an inflection point. So local max would be a none. Local min would be none. And point of inflection, that would be x equals -2 and 4. It's really cool. I'm going to graph that just to see what... No, we can't graph it. Interesting. Very, very interesting. How about that? The last one. All right. Next. The derivative at that point. All right. So g of x equaled 19 minus 6x squared. That means that g of x would be 19x. This would be, we would have had minus 2x cubed, right? So bring it down, and then plus some sort of constant. But we know the 0.37's in there. That 7 equals 19 times 3 minus 2 times 3 cubed plus c. 27 equals 19 times 3 is 57 minus 27, 54 plus c. 7 equals 3 plus c. Plus c equals 4. So that would be that. So that would be g of x equals -2x cubed plus 19x plus 4.